Hello everybody, Chris here. In this mini series, I'm going to be showing you guys the basics of setting up a projectile based 2D platformer inside of Godot. And we're going to be doing it using a 1-bit platformer pack by Kinney, which you can get off of itch.io for free. So I'll put the link to this art pack in the description. And we'll be using it to set up some basic projectile mechanics inside Godot. So for this project, I'm going to be using version 4.3 of Godot, which is in its third beta. Most things will be consistent regardless of version, but one difference is going to be using TileMapLayers instead of the TileMap node. So let's go ahead and create our new project. I'll call our project something like Projectile Platformer 1-bit Tutorial. I'll choose my folder for tutorials and my computer, and we'll just use the mobile renderer. Our graphics are about as simple as they can get. So inside of our project, we're going to need to import that art pack. So I'm going to, in the bottom left for file system, going to right click on the resources folder and create a new folder. So I would generally call my folder something like art or assets. So I'll just make it art here. And I'll right click to open this folder in File Manager. Okay, and navigating to where I have the 1-bit platformer pack downloaded from the website, we can either use individual tiles or just the packed tile maps. So for the project, I'll use the transparent packed version of the tile map. Packed meaning there's no spacing between the tiles, and then transparent means instead of a black background, we just have a transparent background. So we can actually set the background color easily to be whatever we want, and we don't need to worry about filtering out the black pixels or anything like that. So let's copy and paste this into art. I might even create another folder inside of here and say something like Kinney 1-bit platformer, just to know where it came from, and put this in. And let's copy and paste the license into there. So of course, license-wise, you can see the art, of course, is Creative Commons 0. So you can use it in educational or commercial projects. So it's great for stuff like what we're doing here. Let's jump back into Godot now. So back in Godot, the first two things you're probably going to do are start putting down a tile map and creating a scene for your playable character. We'll do both in the first part of this series. So I'll start with the tile map. Let's create a new 2D scene, and I'm going to rename this to be level 1. I'll save it to the project. So we might have a levels folder inside of here. So I'll just call this levels. And in levels, I'll save level1.tscn. Now note in Godot, if you don't know already, file names are generally lowercase separated by underscores. So level_1.tscn. Let's save that there. And now our level is going to need a tilemap layer. So if we search tilemap, you'll see that tilemap is being deprecated in 4.3. Of course, it's still going to work for a while. I don't know when they're actually going to finally remove that. But the new way of doing tile maps is going to be using TileMapLayers. So it's not actually all that different, except instead of having one tile map node and then layers over here in the inspector, you just have a different node for each of your layers of your game map. So you'd probably have like a ground layer, a background layer, maybe like a sky layer, like foreground, background, that kind of stuff. And you would just have a different node for each of those in the hierarchy instead of everything being condensed into one tile map node. So for the tile map layer, we're going to need a tile set resource. So note, you don't need to create one for each layer necessarily. You can just create one new tile set resource, and you can save this to the project and then reuse that across different nodes and different levels as well. So I'm going to right click this and save it. Let's say that since basically tile sets are going to be used exclusively on our levels, that we could create another folder inside of here, and I'll call it tile sets. And inside of here, we'll say Kinney 1-bit platformer, and automatically the extension will be .tres. So we'll save that there. So if we click on our tile set, we'll see a bunch of different subcategories in the menu here. We'll come back to that in a second, but more pressing at the bottom of our screen is the tile set menu option here. So we want to switch to tile set to set up the tile set. And when you're drawing onto your 2D level, you would switch to tile map mode. So we need to be in tile set so we can set it up. Let's go find our monochrome tile map transparent packed.png. I'm going to pop this in here to tiles. And in recent versions of Godot, you can just automatically create the tiles. So I'm going to hit yes to that. and all of these spaces are going to automatically be recognized as 16 by 16 tiles. And you can see because of the transparent version of the tile set, there's only one color here. So in one bit, you would have generally black or white. Some games like to add red to that mix, but one bit would just be on or off, so black or white. And we can use these for basically creating our game levels, and then these sprites down here can be our characters and enemies, as we'll set up in a bit. Okay, so if we were to switch to tile map mode, you can select these tiles now, and when you have it selected, you can left click somewhere. As long as you have tile map layer selected, it'll place it onto that layer. Now you might notice that these pixels are kind of blurry, so we want to change that in project settings. Let's go up to project settings, and then down to rendering textures, and change linear to nearest, and hit close. You'll basically want to do that for every pixel art game, so that all of your pixels render much clearer as they are intended. Now you can build out your ground tiles by clicking on each one you need and left clicking, and then, okay, you need to go across, so now you use the across tile, you click the corner tile, you go down like this. But that can get a little bit tedious, and if you recognize an obvious pattern here, then a better way is to create a terrain set. So in TileMapLayer, under the tile set, the Kinney 1-bit platformer, let's expand terrain sets, add element, and expand terrains, add element. So for each set that you want to basically match with each other, different tiles that go together of the same type, you're going to want to give it a name and then a color. So I'll call it dirt and just leave the color the default brown because, I mean, it's dirt, it makes sense. Mode we can probably just leave at match corners and sides for now. So in order to add tiles to the set and then create a bit mask so that it knows which tile to place in which location automatically, we want to go to the tile map window at the bottom and then go to terrains. So in order to define which tiles are in this dirt terrain set, and then to assign a bit mask to it so it knows which tile goes in which location with reference to the other tiles, let's go to the tile set window at the bottom, and we want to go to paint and then select a property editor, terrains, select the terrain set 0, and then we'll choose dirt here. Okay, so basically find all the tiles which you would consider to be dirt, and I would say that's these 9 right here. And then left click, hold, and you can drag over each of them until they're lit up white instead of grayed out. And then once that's done, you can click on them and you can start assigning a bit mask. So if I left click and hold, you'll see that this makes the squares light up that brown color for dirt. And basically with the bit mask for terrains, you want to tell it which parts of the tile are fully defined as dirt, as opposed to the edges, which are only partially dirt and are probably adjacent to either nothing or a different terrain type entirely. So if a part of the tile is completely enveloped by dirt, then we want it to show as dirt. So that's going to basically look like this in the end. All of these border bit mask squares are going to be left blank. And the result of this is it'll know which tiles to place adjacent to each other, so that we know which ones are facing outwards to non-dirt and which ones are facing inwards to another dirt tile. So if we go to tile map now and we click on terrains, we select dirt here, and then we can start drawing. So I'm going to left click hold, and you'll see that it will automatically change the tiles to be the correct dirt tile based on whatever's adjacent to it. Now it's not perfect with just these 9 squares. You can see that in cases like this where you just have like one tile sticking out, it's not going to fill in the gaps perfectly. In fact, in this case, I think it needs to be at least 3 tiles wide for the tiles to assign, but we can quickly just kind of draw on our tile map and get at least a decent result. So we can kind of just go around the edges and get a pretty okay result. So we can see, of course, that although it does a pretty good job of tiling with just 9 tiles, we can't cover every possible case. So In this square right here, there should really be like a corner piece here and one there as well. I think that's just a limitation of having a simple 9-piece tile set right there for the dirt. Generally, when you have a more robust tile set, you have a bunch of extra pieces for covering these kind of specific cases where you have like corners and stuff like that. But for this case, it might just mean that there might be some limitations in which shape we can create, which is fine. And yeah, let's just kind of do something like that for right now. Another thing you can do for quickly just kind of putting some tiles down is to use the line brush if you want to go from one point to another. Or you can use the rectangle shape and just draw in a huge blotch of tiles. So I could just click here and create ground just like that. Instantly has all the top, left, bottom, and right tiles. And we could go up a little bit like that. Maybe the space needs to be a little larger. And we can come back and kind of fix that in a second. And maybe we have this go on a little bit further to the right. Okay, so for this bit, I'll just switch to the pencil tool and get those left sides in there. And that's probably good enough to at least have some basic playtest space. So let's save the level, and I'm going to create a new scene for our playable character here. So click to add a new scene, I'll right click and change the root to a character body 2D. And then let's rename this to be player. I'll save this scene to our project. So in the root, I'll create a folder. I might call this something like characters, and then hit OK. And then inside of here, I'll create one called player and save it. So let's zoom in on our scene. We'll need a sprite to render our players. So I'll right click on our player, add a child node, and search for sprite. So we could either use a sprite 2D node or animated sprite 2D node. I'll try going ahead with an animated sprite 2D first, since it contains a little extra features for playing multiple frames of texture as a animation. So we'll create that. In the animated sprite, if we go over to the right under animated sprite 2D, we can see animation as a category. We want to add new sprite frames into here. So new sprite frames resource, I'll create that. And since this is a resource, we can save it into our project. I might want to do that so that it's separate from this scene and reusable. I'll right click and save as, and in the player folder, I'll call this player sprite frames.tres and save it. So now we can expand this and add in our animations. So let's create a idle animation. I'll rename default to idle. And FPS, I think we're going to want something like 20. We'll figure that out for sure in a minute. And we want to add in frames from our sprite sheet. So I'm going to click on the add frames from sprite sheet button. And then we'll go to art, Kenny platformer, and the transparent packed.png. Open that up. And if we zoom in, we can see basically the whole sprite sheet. So our frames are going to be 16 by 16. So on the right, I'm going to do 16 and then 16. So these are the frames for our playable character for the pack. So our character is around here for this pack. As far as I can see, it doesn't appear to have like an animated idle animation. So we can just use the first frame here, add frame, and that can just be our idle. And let's add in some other animations. So add animation, and we want a run animation. So we'll select from the pack once again, zoom in, and that is going to be here to here. So I'll add those frames in, and let's also add in a dad animation. And I'm going to make all of these 20 FPS. While I'm doing that, let's actually test the run animation. Okay, maybe that's too fast. Let's make it 10. Yeah, that appears more like what it's supposed to be. Okay, so 10 is actually the FPS for all the animations. And for dad, it looks like it's going to be just this one little frame over here. These actually appear to be other variations on the character. So very simple character, but that's okay. I'll add that in. Idle, run, and dad. And we can just reverse the direction of the sprite when we need it to run left. So this at least gets us our minimum requirements. So another thing we need for our player is to add a collision shape 2D for the physics body. So the character body 2D is a physics body. So I'm going to right click, add child node, and let's get a collision shape 2D. So a collision shape 2D, you could either make it a rectangle, a circle, or a capsule. I'm going to go with capsule. And then we want to adjust these handles right here until the capsule matches our character. So let's shrink the character or shrink the capsule until it basically matches our character. Okay, so regarding the position of the sprite versus the collision shape, generally what I'll do, partially for sorting reasons, is to take all of the characters and position their 0, 0 position. That's where the axes meet, the 0, 0 position, and make that about where their feet are. So I'm going to move the character up to, I guess we'll just say right there, yeah, and move the collision shape as well. So to do that, you hit W to go to move mode or Q to go to selection mode. So in W move mode, you can just reposition it, and Q to select between the different elements on the screen. So W move, and just kind of make it something like that. Okay, so we have a collision shape for our character. We might even want to make it a little bit smaller if we're also going to be using this as the hitbox. So just kind of favoring the player by making a smaller hitbox. And then we position that down there. So if like an arrow projectile happened to hit the ears, we just wouldn't count that as a hit until it hits this blue circle here. Okay, so let's put the character into level 1 for right now. So I'm going to search the file system for player.tscn and add it to the scene, drag and drop. Okay, now we want to hit W to move it, and we'll move our player to right around here. So we have our character in the scene, but right now it's not really going to do anything. We haven't attached a script to the character body 2D. So let's attach a script, and I'll just call it player.gd. Okay, so for our character body 2D, whenever the physics runs on each frame, so physics process, we want it to move and slide based on our input or lack of input, and we want it to be affected by gravity as well. So I'm going to start by implementing the function underscore physics process, and we'll just say move and slide here. So on the physics body, we're going to be telling it to move and slide on every frame. If I hit play on the level scene, you'll see that nothing happens there still. So let's get input from the user to make the character move. So generally for doing that, you want to get an input vector, which is going to have your left, right, up, down movements in one go using the input class. So if I say var direction equals input dot get vector, then here you would give it 4 string names for 4 different actions, which are going to be like left, right, up, and down. Now those actions need to be defined in project settings. So if we go to project settings and then input map, we can say left, right, up, down. And then for each of these actions, you can assign keys or controller buttons in order to trigger those actions. So I'll add A for left, D for right, W for up, and S for down. So there's your standard WASD movement input. So we hit close here. Now for the action names, which are string names, we could just type in left and then go right, up, down for that. But I'm not the biggest fan of that hard-coded approach. So for me, rather than hard-coding the names of the strings into the script, I will actually create a class that will hold all of the player input action names and then use that instead. And I'll also make those variables for the action names exportable so that you can change them without going into your script. I just think that's a little bit of a better way of doing things. So let's create in the player folder. I'll right click, create a new script, and I'm going to call this player input or player input actions actually. And it will inherit from resource instead of node. So let's create that and double click into the script. I'll give it the class name, player input actions, and that'll be much easier to reference this in other scripts like the player. And this will define the action names for the player input during gameplay. So we want to have at export var left And then this will default to left. At export var right, which will default to right. At export var up, which will default to up. And then at export var down, which would default to down. Now, for each of these, you can optionally give it a string name typing. By default, when you just say equals a string, it's going to automatically make these strings. So a string name is supposed to be more of like a constant string that you don't change during gameplay, where generally a regular string you can change all the time or append to it, add things. But for things that are supposed to stay consistent, string name probably makes more sense. So I'll use tabs to make this a little bit cleaner. And that'll basically be all we need from this class for right now, but later we'll come and add extra actions for stuff like maybe a shoot button to launch projectile. So back in the player script, I'm going to export a var, and let's just call this actions, but of type player input actions. And then with this, it's going to expose a field for this resource to be assigned in the inspector. And then we can use these actions instead of hard-coded strings. So it might seem like a lot of extra steps, but I think it just gives you a much cleaner result in the end, because now we can say something like actions.left, actions.right, actions.up, actions.down, and we don't have a hard-coded string here in this file. And that means that we can change it without accessing the player script. So if we click on player now, you can see the actions resource needs to be assigned here. So I'll create a new player input actions. And if we expand that, we have left, right, up, down string names. And these correspond with, in the project settings, our left, right, up, down actions. So also, if we aren't using these names in our actual project, maybe your project uses something different, then you can just change them here, like left action. And then if you go to project settings, you can rename this to left action, and you can change it once again without needing to be inside the script. Also, stuff like that is more handy in projects where not everybody is really touching the code necessarily, and they just, kind of want to be able to use the inspector here and just design things without messing with code. So that's basically what we need there. Because this is a resource, we can save it to the project and reuse it. So I'll right click, save our resource, and I'll just put this in player. So player input actions.tres, save. It's also handy to save resources, because if you ever happen to delete your scene here, these files still exist in your project. So you're not starting from scratch. You can just re-access the same resources or load it into a completely different scene. Okay, so we have our direction for the input. We want to use that to basically change the velocity of the character. So how fast do we want a character to move? Well, that's going to be another at export. So let's say up here at export var move speed, and this will be a float, and we can set it to something like, it's kind of arbitrary. Let's say 50 to start. And hit save. Okay, so there we have our move speed exported to the field here. Now this can be like -50 by default, which is kind of weird. So if we want to prevent our editors from being able to make the move speed a weird number like -50, let's revert that for a second, then we can change this to an at export range instead of just an at export. And we can define kind of what value should be in that range. So we could say something like 0. The max isn't going to matter as much because we're going to make it set to or greater. So it can actually go above this, even if we set it to 100. And then how much we want it to increment, which can be a floating point. So it could be like 0.1, or we could just say 1. And then the fourth parameter is going to be either hide slider or greater or less. So we want or greater so that when we hit save, and we left click and hold on this, it can go to 0 and it can go above 0, but it can't go below 0. So the move speed has to be a positive number now. And I think even if we type something like -100, it'll force it back to 0. So that's pretty helpful for us. And now this is going up 5 at a time. We might not want that, so we could change this to something like 0.2. I wonder if that'll make it a little bit slower here for the increment. Yeah, so maybe that's a little better. So it goes up like 1 at a time instead of 5 at a time. So now let's set the velocity on the character body. So a character body already has a velocity property, and that has an x and y component. So we can say the velocity x is going to be equal to the move speed times the direction dot x, and then move and slide will basically execute and move the character. Okay, so if we go ahead and hit play on our game, then we can see we can move our character left and right, but it's way too zoomed out, and we'd also like a camera to follow our player around the scene. So if we go to the level 1, we can right click on the root, add a child node, a camera 2D, and then this camera 2D, you can see the purple box representing it, the lighter purple. It's way too big at the moment. We want it to be more of a section of our game level, not bigger than the entire game level. So to change that in the inspector, we go down to zoom. I'll set this to 3, and then that's a much more reasonable zoom level. You could even go further or less. And I think you can do like 3.5 too, if you want to. Okay, and then for focusing the camera on our player, we right click on the player, add a child node, remote transform 2D. So this pushes the remote transform position or in other settings onto the other node, which is our camera. So remote transform 2D, and we assign the camera. So now you can see that immediately the camera jumps to the player because that's where the remote transform 2D is. So if we hit play, not only are we zoomed in, but we also have a follow camera. Now, one last thing I want to fix for the video is to make it so that when our character moves to the left, our sprite actually faces to the left. And this is something we're going to want to do for all of our platformer characters. So this will get a little bit involved coding-wise, but hopefully by the end of this section, you'll see that this kind of setup will be really flexible and good for the long term. So first off, I want to go to player, and I want to create a node that's a parent of the animated sprite called facing. So I'm going to right click here and add a node 2D so that it has a position and rotation and scale. And I'll rename this to be facing, as in it's the node which controls which direction the character is facing. And then I'll take the animated sprite 2D and make it a child of that, so that this sprite 2D's scale is dependent on the parent. So if I click on the parent facing node and I go to transform, make sure X and Y are unlinked, and I set X to -1 for scale, then that will make the character flip. Now this also means other objects like a collision shape, if it's a child of facing, are going to flip from the right to the left. So you can use this to control hitboxes as well. Now for the facing node, we're going to want to attach a script to that. And this is going to be more of a component node, not necessarily specific to the player, but more specific to any platformer character within our game. So let's right click and add a script. I'll call it facing, and I'll make it not in the player folder, but the characters folder. So facing.gd inherits from 2D, node 2D. Now for this, we're going to want to get reference to a character body 2D, but not every character body 2D actually has a direction. If we open up the player script, the direction I'm talking about is the direction our character is trying to move. So we declared that in the player script as a local. We want to make that more of a script-wide variable or property now. And the way we would do that is by putting it outside of the function call. Now, I don't want this to just be for the player script, though. I want this to be for all platformer characters in the game. So I'll right-click on the characters folder in our file system to create new script, and I am going to call it platformer character 2D, inherits from character body 2D, create, and we open up that script. I'll give it the class name platformer character 2D so that we can easily reference that in our other scripts like the player script. And inside of here, we're going to have a reference to the direction property. So var direction is a vector 2. Now if we open up the player script, instead of setting the direction locally here, I'm going to remove the var part, and we're actually going to set it to the properties. But right now, the player script does not actually have the direction property because it's not a player character 2D. So we need to change the extents from character body 2D to platformer character 2D, which, if you remember, also inherits from character body 2D. So it's still character body 2D, just with the extra custom steps we created now. And we might also want to give this a class name player if you want to be specific about it. Now, when we're creating the facing component, as I mentioned, we do want to apply it to the player, but we also want it to be able to apply to any other platformer character. So instead of referencing a player, we're going to export var reference a character, which is a platformer character 2D. So if you click on the facing script, we can assign the player, because it is a platformer character 2D, but we don't necessarily need to reference a player. It can just be any platformer character 2D, and that's important. So at the top here, I'll give it a class name facing, just in case we ever need to reference this script. And now what we want to do is whenever the direction changes on our platformer character, we want to respond to that within our facing script. So a not great solution would be to use the process or physics process function and then just check the direction on each frame. But a much better solution is to use a signal from the platformer character script, and then whenever that signal is emitted, we have a function activate inside of our facing script to update the direction or the scale on our facing node so that it makes the animated sprite face left and right. So let's go to platformer character 2D, and this property direction, whenever that's set to a new value, we want to emit a signal. Now we don't have a signal for that yet, so let's create one. So signal direction changed, which is going to take a direction, which is a vector 2. So we're going to pass in that direction argument, and that will be received by our facing script later. So you don't necessarily have to use a setter property, but I think that's a pretty good way of handling this kind of thing. So basically, when we attach a setter function like this, set value, so like colon up here, and then set value colon, then whenever we try to set this property value, it's going to execute this code. So the code we want to execute is going to be direction equals value. So as it is right now, it would be exactly like we didn't have a setter at all, but now we add extra stuff to it. So when the direction changes, we want direction changed to be emitted using the new direction value. Now, we can also take this a step further. We only really want to change the value and emit the signal when the value is actually a new value. So as a precondition, we'll check up here that if the direction is equal to the value, we just return, and we don't set the direction, and we don't emit the signal. That'll just reduce the number of unnecessary direction changed signal calls, because when we have direction changed, we expect the value to have actually changed. So that prevents it from just calling on every set, and then it'll only change when the vector is actually different. Okay, so in the player script, we're setting the direction, which is going to run this code. If the value actually changes, direction changed gets emitted. So now in the facing script or any other script we want to respond to that, referencing a player character 2D, we can put our own setter function to connect to the signal whenever our character changes. So if the character is a valid instance, instance valid is instance valid, and we'll check the current character, then before we add the new character in, we want to disconnect from the old character signals. So character dot direction change dot disconnect and on direction change. Now after disconnecting from an old character signal, we want to set the value to the character property. And then once we have the character set, we want to connect to that character's direction changed signal. So I'm just copy pasting this down here, and we're going to do connect. At this stage, there might already be a character set, but we're setting a new value here. So we want to disconnect old signals, and then we set the character. And once we set the character property in this script, we want to connect to the direction changed signal. Now we get errors because we don't have that callback method. So function on direction change, and as a parameter, we need the direction vector, but I often like to put a p in front of the direction, p for parameter, so that we know that it came from the parameter specifically, and it's not a local variable, and it's not a property of the class. So on direction changed, what do we want to do? Well, first we want to see if the x direction is actually 0, and then just ignore the rest of the function, because if the direction is 0 on x, that means that the character is not moving left and right, so there's no need to flip the direction of the facing component. So if p direction is equal to p direction.x is equal to 0, we'll just return. Okay, otherwise, we want to take the scale.x, and we want to set that equal to, let's say, the absolute value of the scale.x. So this is the raw value of the x scale. Whether it's positive or negative, it's going to return a positive. And then we want to figure out what direction we should be making it face. So if we take the sine of the p direction.x, then that's going to give us either a plus or -1. Now it can also be 0 if this is 0, but we already handled that case right here. So we're not going to do anything with the scale when the x direction is 0, only when the character is actually trying to move to the left or actually trying to move to the right. So this is going to be plus or -1, and this is going to be the raw value of the scale. So when the character is facing left or moving to the left, this is going to make the scale, whatever it is, raw value times -1. And whenever it's facing to the right, it's going to be the raw value times 1, which is going to give us our left-right facing direction. So hopefully this coding setup made sense. The reason we create a separate script for facing is so that it's a reusable component. We create the platformer character 2D class so that we can have certain aspects applied to different characters in our game without re-implementing them in every enemy script. And then we inherit from that script so that that direction is part of the player as well, but not exclusive to the player, because any platformer character 2D can now have that. So we'll be able to easily reuse that for our enemies later on. Yeah, and hopefully this setup with a custom signal all makes sense. Signals just kind of reduce a lot of the unnecessary function calls you need to have so that you're not calling process to check on a variable every single second of the game, or millisecond even, but rather you're just waiting for something to change and then your code executes. It's just a better way of doing things. So if we hit play, we're going to have a character here. If I move to the left with A, you can see that it flips to the left, and then D will flip it to the right. So back and forth. And if the character's not moving, nothing happens, which is exactly what we expect. So to show what this is actually doing, if I expand the remote view, which is our current gameplay scene, local is for the editor, remote is for gameplay, and we expand player, we can click on facing and see that the scale is set to -1. Now if I move to the right, the scale is set to 1. And remember that as the parent of these child nodes, whatever happens to the scale affects what's down here. So we don't need to change the scale of the animated sprite to face left because the parent, the facing node, already does that for us. So this controls all of its child nodes, and if you need it to flip directions, you just make it a child of facing. So that should pretty much be a good setup for the start of this project, I think. I'll have a link in the description if you want to download the part 1 of the tutorial. And of course, on each part, I'll have the updated version of the project going all the way to the conclusion, and those will be on my Ko-Fi and Patreon pages. So if this tutorial helped you out, thanks for watching to the end. I've been Chris, and I'll see you in my future video content.